Hi everyone, welcome to lesson 2.10, derivatives of inverse functions. So in this lesson we're going to be looking at the application of inverse function properties to derivatives of inverse functions, and we're also going to be applying the rules of derivatives to inverse trig functions. First, we'll look at a couple of definitions. Here we have the definition of an inverse function. So you may recall that a function g is the inverse of a function f. If f of g of x is equal to x, for every x in the domain of g, and g of f of x is equal to x for every x in the domain of f. So the first thing that you do is you look at the domains of f and g, and then you eliminate any values that could cause the function to be undefined or imaginary if you're working over the real numbers. And then you substitute the inverse into the function, and you see if you get x. Then you substitute the original function into the inverse, and reducing algebraically, see if you get x. But that inverse function g then is denoted by the symbol f inverse, or f to the -1 power. We also have this reflective property of inverse functions, and it's called the reflective property because inverse functions actually have reflective symmetry across the line y equals x. And the way this works out in a coordinate plane is the graph of f contains the point AB if and only if the graph of its inverse, f inverse, contains the point BA. And this makes sense because what we're doing is we're actually exchanging the domain and the range when we find an inverse function. And in fact, that symmetry that I was talking about, the line y equals x, you could think of just simply leaving the function where it is, but reflecting the coordinate system itself so that the x-axis becomes the y-axis and the y-axis becomes the x-axis. And so in this way, we've exchanged the domain of one function in place of its range.